Okay, so today we're going to look at a partial variation. Yesterday we looked at direct variation, and today we're going to look at partial variation. So partial variation is a relationship between two variables in which the dependent variable is the sum of a constant number and a constant multiple of the independent variable. So it's a two-step process. So direct variation again was y equals kx. That was a one-step process. Where in partial variation, it is y equals mx plus b. It is a two-step process. Notice that when we were looking at direct variation, the constant of variation was k. And when we were looking at partial variation, the constant of variation is m. They both mean the same thing. We talked about this the other day, that the constant of variation could be referred to as k or m, the same thing. So when we're looking at the partial variation, we notice that there's a second letter, this b, and this b represents the number added. It happens to be where the graph starts, because remember that when we were looking at direct variation, the graph always began at the origin. When we're looking at partial variation, the graph is going to begin at B. So here's an example of what this looks like, just so we have something to hold on to. So it says, to take a taxi ride, it costs $3 as a flat fee plus 50 cents for every kilometer traveled. That means that no matter how far you go, you have to pay this $3 to begin with, and then you're going to add 50 cents for every kilometer traveled. So let's write the equation. The base equation was y equals mx plus b. So when we look at this, well, what is y? What are we trying to find? We're trying to find the total cost. And that's going to be equal to, what do we multiply every time? It was 50 cents times the number of kilometers traveled plus, what did we have to add to begin with? $3. So our equation would be C equals 0.50, K for kilometers if we wanted, plus 3, where C is the total cost and K is the number of kilometers, or the distance. So what would that look like as a table of values? If we set this up, if we have our x and our y, we know our x is the kilometers and our y is the total cost. If we go nowhere, it still costs us $3. If we go 1 kilometer, it's going to cost us $3.50 because we had to add 50 cents for that kilometer. If we go 2 kilometers, it's going to cost us $4 because it's another 50 cents. If we go 3 kilometers, it's another 50 cents, so it's going to be $4.50. And if we are going to graph this on the x-axis, we know we're going to put the kilometers, and on the y-axis, we're going to put the total cost. Now this graph does not begin here at 0, 0, where direct variation did. Instead, it's going to begin here at 3. And we notice that when we go over 1, it's going to go up to $3.50. And when we go over to 2, it's going to go up to $4. And when we go over to 3, it's going to go up to $4.50. This initial point here, though, is at 0, 3. Okay, and it will keep going depending on how far you drive. Okay, so that's an example of partial variation. So let's just remind ourselves of the differences between partial variation and direct variation. So we have direct variation and we have partial variation. Direct variation begins at the origin, right here at 0, 0. Partial variation, we'll say begins at here, begins at the point that is 0, b. This is 0 and b. And this b refers to the initial value or the fixed rate. In our example, it was the starting cost. Okay? This is direct variation is a one-step process, and partial variation was a two-step process. The equation for direct variation was y equals kx, and the equation for partial variation was y equals mx plus b. Okay, where in this example, k is the constant of variation, and in this example, m is the constant of variation. So now you're going to have the chance to do some practice questions looking at direct variation and partial variation.